Thanks for joining me today. My name is Hossam Barakat, and I work as a tech lead with a company here in Sydney called Willow. This is my Twitter handle and website if you would like to follow me or reach out to me with any questions that you have. Today, I would like to talk to you about practical domain-driven design with EF Core. If you have any questions during the call or the talk, please feel free to send the questions on Slack. I will look into all of the questions after the talk and I will answer them there. I've been practicing domain-driven design for a long time now, and one of the common challenges that I have found when I worked alongside other developers is how can we apply the domain-driven design concepts to a legacy code base that we have inherited from a previous team or a previous company or third-party vendor that basically worked on that code base. And that's going to be the focus of my talk today. How can we apply the domain-driven design into a legacy code base? And we will be using EF Core to make sure that that domain model that we will be building can be materialized into a relational database. Let's start by defining what's domain-driven design. Domain-driven design is an approach to software development that centers the development on programming domain model that has a rich understanding of their processes and the rules of the domain. So as developers, we will be building a domain model. That domain model will have business rules and processes, or will help us to solve that particular problem that we are trying to solve. So what's a domain model? A domain model is an object model of the domain that has both behavior and data. So basically, we will be building classes to represent the domain. Our classes will have behavior, which is usually represented with methods in C#, and it will also have data, which are usually represented with properties. There is another key definition for the domain model, which is it's a system of abstraction that describes selected aspects of a domain and can be used to solve problems related to that domain. So as developers, we will not be representing every single aspect that exists in the business domain that we are working on. We will focus on the areas that will help us solve the business problem. Over time, our domain model or our classes will keep growing, and this will make it harder to understand and difficult to maintain. Thanks to domain-driven design, there is a solution for that, which is using the strategic design pattern. The idea is pretty simple, but it's usually hard to apply at the beginning, which is when you have a big system, you usually want to split that system into a set of bounded contexts. Bounded context is a defined part of a software where particular terms, definitions, and rules apply in a consistent way. It also provides us with a clear boundary between different parts of the system. So as we can see here, we have two bounded contexts, sales and support. Each of them have different terms, and each one has a clear definition that can be understood by both developers and business experts. Some of the terms that exist in the bounded context of sale exist also in support, like customer or product. The meaning might slightly differ between the different bounded contexts, but the key thing here is both business stakeholders or domain experts and developers have the same understanding. Our focus today will not be how can we split a big system into a set of bounded contexts, but we will focus on how can we apply domain-driven design, the tactical parts, into a particular bounded context. But which one should we start with? When we have multiple bounded contexts, we should start focusing on the core domain. The core domain is the bounded context that provides the most value for your company. So it's that part of the system, if you removed it, your company wouldn't exist. That's usually where you try to start. And this is where you should be applying all of the concepts like services, entities, value objects, and repositories. But this doesn't help us actually solve how can we refactor a legacy code base towards all of those concepts to be applied in there. And this is where we will spend the rest of the talk today, showing you how we do refactor an existing legacy code base. But before we do that, I just want to remind you that you shouldn't apply domain-driven design for every bounded context. You need to assess the value that you will get from applying domain-driven design to a particular bounded context, because by nature, some of the bounded context might be just crowd-based operation, like maintaining a product catalog with their names, categories, and not much business rules like around the pricing or things like that. So in that case, if it's just a crowd-based operation, you will not get much value of applying the domain-driven design. Sometimes some of the domains might be a specific domain like the search. If you have a search, you might be better using an existing service like Elasticsearch or whatever product that existed solves this problem. And you might not get much value from applying domain-driven design in that particular domain. So keep that in mind. You shouldn't be applying domain-driven design for every bounded context. So let's start by showing how can we refactor a legacy code base towards more of a rich domain model. And we will be applying that by using a sample domain that I have extracted from a recent project that I have worked on. I have simplified, really made it very, very simple to make it easy to go through the code base and some of the smells that we can find in the code, and how can those code smells help us refactor the code towards more of a rich domain model. Our sample domain will be a florist website. That florist website enables the customers to subscribe to products such as a small weekly punch, large weekly punch, and each product would have a price. And one of the other things that business rule is the more amount of money the customer spends on our portal, they will get a discount based on that money spent. The business rule that we have right now, we'll go through the journey of a customer subscribing to a product and how can we improve the code base that's covering that area of customer subscribing to a particular product. Our current domain model that we will be working with, we have a customer. That customer has email, first name, last name, the amount of money spent. So whenever they subscribe to a product, we can identify the right discount that they will get. We have a product where we have the name, billing period, if it's weekly or monthly, and the amount for that product. Whenever a customer subscribes to a product, that generates a subscription. And that subscription will have the actual amount that the customer purchased this product with, when this product will expire using the current period and date, and then we have a status, which is either active or canceled. Immediately, once you see this domain model, you can say, actually, this domain model doesn't satisfy the definition that we said about a domain model to have both behavior and data. Because as we can see here, we only have data. It's only properties in that particular domain. So let's switch to the IDE to go through the code and showing you how can we refactor towards a rich domain model. Here's my IDE. I'm using JetBrains Riders for today, and our code is written in C# and it's .NET Core API. We'll be using .NET 5 and EF Core 5. The source code of this repository before the refactoring and after the refactoring is available in GitHub. I will share the links towards the end of the talk. So here's our controller. We have a request for a customer to subscribe to a product. We are using the excellent library mediator from Jimmy Bogard. And this is right now becoming commonly used in a lot of code bases. It provides us with that benefit to make our controllers really small, and we have the business logic in class to handle a particular request. So we have that request, and we have a request handler to go through. We'll go through all of the logic of how a customer subscribes to a product in a minute. Just go through the rest of the classes that we have in our project. We are using EF Core, so we have a DbContext that includes 3 properties, 1 for each table. We have the domain directory that includes the classes that we have seen in the diagram. As we can see, it's just properties in here. And we have a base entity that includes an ID, which is the primary key of my entities. And we have a service which is sending an email, which is just pretty much doing nothing, but it just gives us that sample of if we would like to have a side effect like sending an email or sending an SMS. Let's get back to our request handler to see what's actually happening in there. Also, before we start, we have an integration test that we'll be using to make sure that our code as we refactor it is not broken. And this is really important with any code base that you are working on. So here is our customer subscribing to a product. We are loading a customer from the database, loading the product. Then we are calculating the subscription amount. And that is based on the amount of money spent by the customer. If the customer spent more than $100, then they get a 20% discount. If they spent more than or equal 1,000, they get 50% discount. It's really simplified, but it will just convey the idea of the rules that could apply whenever a customer subscribes to a product. Then we are calculating whenever a subscription will expire based on the billing period of a product. So if it's a weekly, we add 7 days. If it's a monthly, 1 month. The next section in this method is creating a subscription, setting the properties of that subscription, adding it to the customer subscriptions, increasing the amount of money spent, saving everything in the database. After that, we send an email to the customer, letting them know that they have subscribed to our product. This is a common pattern that you see in a lot of code bases, and one of the first things that I see with this method, it's a long method. I can't even fit it on a single screen. I'm using a large font, but even if I use the smaller font, it will be hard to have everything in your mind when you work with such long method. And the first thing that I do when I have such long methods, I break them into smaller ones by applying the extract method refactoring, so I can minimize the cognitive load that I require when I work with this code base. Usually in legacy code bases, you find comments or regions that's kind of the smells that will hint you to start where and how to break that long method. So the first thing we will do, we'll just extract that section, which is calculating subscription amount. Then the next part here is calculating the current period in date. So I'll extract this to another method. The last part here is creating a subscription and adding it to the customer. So we'll extract a method and we'll call it add subscription to customer. Here you go. So right now, as you can see, the method is broken and it's much shorter. Still, there is a lot of things to be improved. And we'll see as we go, how can we improve that logic right now. So let's start looking at the methods that we have extracted. But before we do this, since we have done a refactoring, let's make sure that we didn't break the code as part of that refactoring by running the integration tests. And the tests pass. Let's start by looking at this first method that we have extracted. We create a subscription, we add it to the customer subscriptions, increase the amount of money spent. As I read through this method, I can identify few code smells. The first one, with creating the subscription, we are using the property setters to initialize the subscription, and we are using the object initializer. But the key part here is we are setting the properties directly. And as a consumer of that domain model, nothing is stopping me from creating the subscription in an invalid state. So I can create a subscription in a canceled state. Technically, that's valid, but from a business perspective, there is no such thing as creating subscription in cancel. It's usually either active, or maybe if you didn't collect the money, you will create it in pending. After getting the money, you will make it active. In our domain, it's either active or canceled, and the default is active. So that's an issue, right? We want the code to help us as consumers of that domain model to avoid making those mistakes. Nothing's stopping me from creating a subscription with a negative amount, or a subscription without a customer or a product. If I did that, I will get an error when I save that data into the database because there is a relation between the tables that might be broken, but I don't want to wait till that last minute when I get an exception from the database. I want to have all of these validation rules as part of my domain model. And the good thing with C# is we can do this by using a constructor. So I can go here in my subscription class. I will update all of the properties to be privately set. So only methods inside my subscription entity can change the values of those properties. And I will introduce a parameterized constructor where I can pass the required parameters to initialize a subscription entity. To avoid spending a lot of time with the writing and all of the spelling mistakes, I have a bunch of code snippets that I will be using today. So here we go. We have our subscription constructor, where I added the validations of the customer, product, amount. I even set the default value for the status. I updated all of the properties to be privately set as well. With that change, I will update the consumer code to use that parameterized constructor. And with this refactoring, let's run the test to make sure that nothing is broken. and we managed to create the tests. The error that we are seeing here is basically EF Core unable to load that entity from the database, because this is a limitation that we have, unfortunately, with EF Core right now. When you have a constructor with some of the complex type, it cannot use that parameterized constructor. So the solution to that is to use a private constructor that can be used by EF Core. And we are using private constructor here, parameterless constructor, because that can be used by EF Core, but the consumers of my code still has to use that constructor with parameters. So we kind of satisfying both EF Core and the consumers of my code. I know that some developers prefer to have two domain models, like having a subscription domain model that have all of the business rules, and maybe another model to include anything relevant to EF Core. In my experience working with legacy code bases, I find that over time, it's much easier to work with those existing entities, move behavior into them. But again, that depends on the code base. And if you are working with two domain models and having a lot of mapping, that's up to you to decide. But in today's talk, we'll be going through updating the existing entities of the domain model. So now let's run the tests. And the test is passed. Let's get back to our request handler to see that method. The second code smell that I can see here is there is that relationship between the subscriptions and the money spent. So right now, whenever as a developer I modify the subscriptions, I need to remember to update the money spent. And that's not really a good thing, because it's usually the source of bugs. Because I might end up adding a subscription and not updating the amounts of money spent. I update the money spent and I forget to update the subscription, and so on and so forth. So ideally, those properties should also be privately set and modified via behavior inside an entity. And if we read those 3 lines, this is basically like adding a subscription to customer, even the method name kind of giving us this hint. So we can basically move this whole behavior to be part of the customer entity. And we update those 2 properties to be privately set, and they cannot be modified outside the customer entity. And this means that when we move that to be part of the customer, the consumers of my code base will not have to remember, they don't need to remember that whenever I update a subscription, I update the money spent, they just want to call add subscription. So let's do that. I will move this method by making it non-static, and I will make it an instance method of the customer. So now this method is part of the customer. I can rename it and remove that to customer suffix. Here we go. So we have moved the behavior to be part of the customer. This enables us to make the money spent as a private property, private set, and we need to do the same thing for subscription. The only difference here is subscription is a list. And to make the subscription list exposed as a read-only, we can use something like iRead-only collection, which is a base interface that the list class inherits from. However, the problem with that is the consumers can easily cast back to a list and use all of the methods in that list. So in order to properly expose an immutable subscriptions list, what we are going to do is we will use a private packing field for this property. So we'll introduce a packing field, and I'll just move that field closer to the property. I will update my behavior inside the customer class to use that private packing field. I don't need that setter because we are going to make it a read-only. So I'll remove that setter, and we can move this to be expression body. And now we have that private packing field. I can modify this property to be iRead-only collection. Still, nothing is stopping me from a consumer perspective to do something like customer. After I add a subscription, I can go and say customer.subscriptions. Very smart, so we can go and say cast as list of subscription. And when I do this, I can call clear, right? Nothing is stopping me from doing something like that. We shouldn't, but nothing's stopping us from doing it. And it's pretty easy to cover that scenario as well by going here and using the as read only method. So even though the compiler will not complain immediately in the runtime, if we run the tests or if we run this code, we will get a runtime exception. So it's pretty easy to cover that scenario by using the as read only as part of my method. Let's get back to the slides to see what we have done so far, and then we'll see what other code smells we can have. The first thing that we have done is minimize the cognitive load required from us as developers by breaking that long method into smaller ones, which provided us with the three methods that we have worked with, which is calculate the subscription amount, calculate the current period end date, and add the subscription to customer. We started looking at the method add subscription to customer, and that enabled us to start avoiding the public setters when we are creating a new subscription entity. And we moved to a parameterized constructor, which enabled us to add validation. We added the default value for the status as well. We have moved all of our properties to be privately set. Next, we have pushed the behavior of adding subscription to be part of the customer. So this tells us that usually in those legacy code bases that the behavior exists, but it might not be part of the domain model. In our case, it existed in the request handler. In other legacy code bases, it could be part of a domain service is a valid point. I should say just a service or a utility or sometimes an extension method. So usually when you have those kind of anemic domain model, the behavior exists, but we just need to move it to the domain model, which is the right spot for it. We have updated our subscription and money spent to be privately set. So the money spent, we use the private set for the property, and we use a private packing field for the subscription list, made it immutable by exposing it via iRead-only collection. And to avoid any runtime casting back to a list, we use the as-read-only here, which will throw an exception for any consumer. Let's get back to the code and look into the next method that we have extracted and how can we improve it. The next method here is calculate the current period end date. And this method is interesting because it's a static method that accepts a single parameter. And all of the code that exists in that method depends only on that passed parameter. This is usually a smell that tells me that this whole behavior should be an instance method of that particular class, especially it's a domain model entity that exists. So what I would do right now is I would refactor this method and we'll make it an instance method of the product. So we're kind of pushing more behavior towards my domain model. Now opening the product class, we can see here our instance method. One thing to keep in mind, this method have a switch statement over a C# enumerator, which is the filling period. In our case, we only have a single touch point where we have that switch statement. However, in a lot of the legacy code bases, you might find there are heaps of touch points in your code base that have that switch statement or if-else condition on an enumerator. And that usually makes it harder if we would like to introduce another value in my enumerator. If I would like to introduce quarterly or yearly, I need to go and find all of those touch points and update them. Usually when you find such pattern or smell in your code, you should refactor from a C# enumerator into enumeration classes. We will not cover that today because we only have a single touch point, so it will be overcomplication. But it's just something that you need to keep in mind when you work with legacy code bases that have a lot of switch statements over enumerator. So as you can see with this change, we have more behavior pushed into our domain model. And we should run the tests because I forgot to run it in the last refactoring. Sorry for that. Here we go, the tests are still passing. Let's get back to the code and see what we have right now. The third method that we have extracted. This method is also static and it accepts two parameters. Both of them are entities in my domain model. However, the logic here of calculating subscription amount might not really belong to one of them because I need both entities and the values from both entities to calculate the outcome. And this is usually an indication that we should use a domain service, which is basically a service that can hold a business logic when we have a logic that cannot really fit into a single entity in my domain. And that's what we are going to do right now. We'll create a domain service. We will call it subscription amount calculator. And I will move this method that we have here to that domain service. Yes, please. So as we can see with this refactoring, we have the method become a static method of the calculator. I'll just run the test to make sure that nothing is broken. One of the things that you usually find with those domain services is I would like to still have my unit tests to be able to mock the domain service so I can test different paths or different outcomes from the domain service. So that can be easily achieved by introducing a base interface for my domain service. So I'll create the interface here. It rather do that for me. And then I will update the method. I will make it non-static and we'll pull this member up. So it will just add that method to the interface. So we have here, we have the interface with the calculate subscription amount. Then in my code, a request handler, obviously I need to inject that interface via my constructor. I will introduce a field, and then I will use that field to call the method rather than calling the static method that we used to have. So this enables me to register that base interface into my DI container and resolve it from the DI container. And it also enables me in my test to mock the behavior and test different paths in my code base. Speaking of test, let's fix that and introduce the parameter that we just introduced into the request handler. And since it's an integration test, I will just use the actual method. So I will pass the concrete implementation of the interface. Running the tests. So far, so good. So as you can see, all of the three methods that we have extracted so far were actually belonging to different parts of my domain. And what we have done is step by step finding the code smells, pushing the code towards the domain model. So my domain model right now have more behavior into it. So it becomes more data and behavior as we would like it to be. Let's review this request handler. We can see here we have two lines, the last two methods that we worked on, calculate the subscription amount, and then calculating the current period end date. We are using the outcome of those methods and pathing to add subscription. However, there's something interesting with those two lines. The first line here of calculating the current period end date is just calling a method of the product, passing the outcome to another method that accepts the product as a parameter. So this usually tells me that I can push this line of code to be part of the add subscription. So let's do that. First, I will inline the variable, so the call of the method becomes part of the call of the add subscription. Then in the add subscription, I will just directly call, instead of calling the method here or using the parameter pass, I will just do it as part of the call to the constructor of the subscription. This means that this parameter is no longer required. I can safely remove it. Again, looking at that line of code of the subscription, I can see that I'm passing the outcome of that calculate current period end date to the subscription constructor, which is also accepting the product as a parameter. So I can do the same thing, which is adding or calling this method directly in the constructor, which means that parameter is useless and I can remove it safely. So as you can see, the code is driving how can I move the behavior towards which part of the domain model. And now removing that parameter means in order to create a subscription entity, less parameters required. So it makes the code more easier to maintain. Let's run the tests. Tests are passing. The second line here that we talked about is slightly complicated because it depends on that domain service that we are resolving from the DI container. So, but still it accepts product and customer, and I have the product as well as the customer as part of my add subscription method. So in order to push that behavior to be part of the domain model, while maintaining that capability of resolving the interface via the DI container, which also enables me to mock different behaviors or different outcomes of the calculate method, I can use the double dispatch pattern. The double dispatch pattern enables me to, instead of passing the outcome of the domain service, I will pass the domain service itself as a parameter to my method here. So I will just inline this variable. So when we delete the parameter, it just becomes easy. And then I will pass the calculator itself as an additional parameter. I will use add parameter. And then going to that add subscription method, I have the calculator. So instead of passing the subscription amount, I'm going to go and call calculate subscription amount. This accepts two parameters, the product, which I have, and then it needs the customer. And the customer is basically my class, so I can just use this. With that, that subscription amount parameter is no longer required. And calling the domain service method becomes part of my domain model. And I still can resolve that domain service via the DI container and inject it to my request handler. So as you can see with these refactorings, my request handler is much smaller right now. So this tells me that all of the behavior that existed in here previously should have been part of the domain model. And in a lot of legacy code bases, that's usually the case. The behavior exists either in the controller or a service or a request handler, like what we have seen here. Let's get back to the slides to see the refactorings that we have done so far. With the calculate the current period end date, we move the behavior to be part of the product entity. With the domain behavior of calculating subscription amount, we introduce the domain service to encapsulate that logic because the logic didn't really fit into a single entity. We have also used the double dispatch pattern to pass the domain service to my domain model, which also enables me to still inject that interface via the DI container into my request handler. Let's get back to the code. The last line of the code here is sending the email. And usually in legacy code bases or even in any code base, you can find a bunch of side effects that happen because a customer subscribed to a product or something that has happened in my domain. And it's an application level responsibility. It's not part of my domain model to send an email. So what should I do with those code? How can I make my code open for extension? Because if I would like to add another behavior like sending an SMS, I need to add few lines of code here to send an SMS. If I want to, let's say, add a record of audit entry or something, again, I need to have another line of code here and so on and so forth. The solution to that is to start introducing the domain events and having domain event handler. Domain events usually used to represent the intent that something has happened in the domain. And we don't care who is interested in listening to those domain events as a domain model. We just need to raise that domain event. And then we have a bunch of event handlers that listens to that domain event. So if I would like to have a send the email functionality, I will have an email sender handler that will listen to the domain event, send an email. If I would like to extend the functionality by adding another behavior, I can just add another event handler for the SMS, another event handler to do something else, and so on. To introduce the domain events into my code base, we will do few steps. It's a little bit involved, so I will cover that by the slides first, and then we'll see how will we apply it in the code. First, we will update our entity. So whenever a behavior is called, like a customer subscribing to a product, we will add a domain event. We'll raise a domain event. So in our entity, or each entity in my domain will have a list of domain events. We will do this by updating our base class to include a list of domain events. And because any change that happen in my domain usually needs a save to the changes to the database, so this means since we are using EF core, we will be calling the save changes, right? So what we can do is we can use the EF core 5 save changes interceptor to listen to that call of save changes. And that will be kind of the domain event dispatcher that will use the change tracker functionality from EF core to publish the domain events that exist in the entities. We'll be using the publish method from Mediator, which enables us to have that pops up mechanism, even though it's in memory, but it provides us with that pops up, so I can have multiple event handlers for the same event. That's what we're gonna do. So let's switch back to the code. First, we need to introduce Pays interface where all my domain events inherit from. Since my domain events will be published to Mediator, I will make this inherit from iNotification. I can immediately make my domain events inherit from iNotification, but I think that using that marker interface makes it a little bit clearer. Since we said we want to maintain list of domain events in the entity, I will update the base entity to maintain a list of domain events. And similar to what we have done with the list of subscriptions in the customer, we are exposing this via an immutable list, and you can modify the behavior of those, or just add or update via methods in that entity. Now we have that Pays interface, and the Pays entity include a list of domain events. Let's introduce our first domain event, which is a customer subscribed to a product. And as you can see, I'm using the past tense in my domain event. And this is usually how you describe your domain events. You usually want to describe something that has happened in the past. I have a good snippet with the domain event and how the handler would look like, so we don't write all of that. Just import the references. So my domain event just inherits from iDomain event, has two properties, customer ID, product ID, and then I have a customer subscribed to a product handler. In this case, it just send an email. So I kind of moved that behavior of email sender from the request handler to be part of the event handler. So this means I can update my request handler to remove that logic, because that will be triggered via the event handler, as we will see in a minute. I'll just remove this line of code, and I no longer need this parameter and no longer need this field as well, because I have moved that logic to be part of my event handler. So right now we have an event handler. We need to update our entity. So whenever a customer subscribes to a product, we need to raise that domain event by calling the add domain event method. So each time we add a subscription, we update the list of domain events that exist in my entity. So far, we have an domain events in my entity, and we have event handler that can handle that event whenever it's raised. The last piece is gluing those together using the save changes interceptor from EF core. I have that behavior here as well. Instead of writing it, I'll just uncomment and we'll read it together. So this is my domain event dispatcher, which is listening to the saving it changes. So this means that the events that we are publishing will be published before the entities have been saved into the database. And that might raise concerns, because what if I sent the email and fail to save the data into the database because of some network issue? Usually after I use this pattern, I apply another pattern to improve the resiliency of publishing the domain events, which is called store and forward or outbox pattern. We will not cover that today, but I highly recommend looking into that pattern because it will definitely improve the way you publish domain events, and it will improve the resiliency of that. So you don't have that concern around, did I save the events or did I publish the events and failed to save the entities in the database? So in our case, we are using just in-memory pops up. So we'll use the change tracker to find all of the entries in the change tracker with domain events, loop over the domain events and publish them to Mediator. Mediator will find all of the event handlers and will send them that particular event. Running the tests. Obviously, I don't have tests in this code base right now for the domain event dispatcher or for the event handlers that we have introduced. But ideally, as you refactor your code base, you should update your tests. Either they are integration or unit tests based on what you are working on. So with that, we can see that our code base right now with the request handler, it's pretty straightforward. Loading data from the database, calling a behavior in my domain model, saving jet savings. One last thing that I want to cover with that saving changes interceptor, how would you register that in the DI container? Because my domain event dispatcher have another dependency that we would like to resolve in the runtime from the DI container, which is iMediator. What I want to do here in the startup, I need to register the domain event dispatcher as a scope because this matches my DbContext. And then when I'm adding the DbContext, there is an overload here that accepts a service provider, which means I can easily go and say service provider.get service, and this will enable me to resolve the domain event dispatcher from the DI container, which will also resolve any dependencies for my domain event dispatcher. So that's how can we introduce the domain events in my model. Let's get back to the slides. So as we said, we had an entity. Whenever a behavior happens to the entity, we raise a domain event, listen to the save changes from DbContext, use the save changes interceptor to publish the domain events via Mediator, and we could have multiple event handlers for my domain event. As we have seen so far, all of the triggers for the refactoring is the code, and that's really good because all of the code smells have been driving those refactorings, and we are pushing more behavior into my domain model. But that's not the only reason or the only trigger that I would have a refactoring in my code base. When we work in a domain-driven design, we usually have a lot of conversations with business experts. And one of the key concepts with domain-driven design is using ubiquitous language. So both developers and business experts or domain experts use the same language. And it's not only in conversation, my code should also show those behaviors or show the same language as well. So a very simple example is when we talk with business experts, they keep using the word customer name. Like I would like to send an email to the customer with the customer name and that particular content. Or I would like to have a report and I would like to show the customer name and the amount of money spent for that customer. And they never use that customer first name, last name. However, if we look at our code, we will find that our code is just all about first name, last name. And this might be a good trigger to start updating my domain model to use the same language used by the business experts. So in this case, we can use something like value objects. Value objects provides us with that capability where we have two objects can be equivalent when they have the same value without being the same object. So if I have two instances of the customer name, if both instances have the same value for the first name and last name, those instances will be equal, even though they are not the same object. Thinking about that with the C#9, this is pretty much the records in C#9. And that's what we're going to do right now. We'll just introduce a record to represent the customer name. So here is our customer name record. Then I will update my customer class to use that customer name. Customer name can also be used in a parameterized constructor, and I can make it with a private set. So I will just update my properties similar to what we have done with the subscription entity. So here we go. We have a private constructor to be used by AF Core when loading entities from the database. We have a parameterized constructor to be used by developers consuming the domain model. and we have the validations here while we are creating the customer entity. I have also made the customer name privately set. The next thing that we need to think about with that customer name recorded change is how can I save that customer name into the database with EF Core? EF Core provides that concept that's called owned entities, which enables us to map those value objects into the same columns that we used to have in the previous sample with the code base of property of customer name and last name. So on the entities, we just use owns1, and then we map the property first name to the column first name and last name to the last name. One of the important things to keep in mind when you work with owned entities is the default convention. It uses a customer name underscore first name, excuse me, or customer name underscore last name. So we have to be explicit with which column we are saving the properties to. The second thing that you need to keep in mind is you need to keep an eye on the generated SQL statements when you use owned entities and make sure that it's generating the right SQL statement, because you don't want to end up with performance issues because you used the wrong configurations. With that, let's update the customer name to be used here in my code to pass the customer name instance. Let's run the test to make sure that everything is working as expected. Cool, now we have the customer name. Let's get back to the slide to see what we have done. We have moved away from the primitive obsession of using string for the first name, string for the last name, and moved towards value objects, which enable us to use the same ubiquitous language that our business experts are using, which also enabled us to have that C# record to represent our value object. We used the owned entities to map our properties to the same columns that we used to have previously. One of the things that I will mention here with EF Core 5 is that navigation.is required. This is really a cool addition in EF Core 5, which enables us to have a clear definition that if some of the columns that we are working with are required or mandatory on the database level, we can use the is required property. And when we run the EF Core to generate the migrations, if you are using EF Core migrations, those migrations will be generated correctly. Previously with EF Core 3.1, there was issues that owned entities were always assumed to be nullable, which was generating a bunch of migrations that are not matching what we want to have if we have required columns. The next thing that I would like to talk about is the repository. In a lot of legacy code bases, you might find repositories. Repositories in general are okay, it's a good pattern. However, with a lot of the legacy code bases, I usually find two key issues. The first one is the massive amount of methods that exist in a repository, like get customer by first name, get customer by last name, get customer by first name, email, and last name, and so on. And the second parameter is, or the second concern, is that something like that save method, which is calling context.savethechanges. Context.savethechanges sends all of the all of the entities, not just the entity of the customer, to the database. So if I have a little bit of a complex behavior that uses multiple repositories and I call the save method from different repositories, I might end up with all sorts of errors because I saved in the wrong timing or data inconsistencies, and it usually becomes pretty messy very quickly. So what I have seen as patterns to solve that save method is using the unit of work. The unit of work is a solution for that issue because we no longer have that save method as part of the repository. It just becomes part of the unit of work, which abstracts that subscription context or the DbContext. However, if we think about it, the subscription context itself is a unit of work, and it's a class that we are maintaining. So instead of introducing a wrapper for our subscription context, what we can use is we embrace the DbContext class to be our unit of work. And in that, we can have all sorts of methods like begin transaction, commit, rollback, whatever we want, we can just add it in here. And for testing perspective, we can make that subscription context inherit from an interface so that I can test different behaviors for my DbContext. So this will help us with the unit of work and getting around that save method that existed in the repository. However, that doesn't help us with the massive amount of methods that exist in the repository. There are different patterns that can help us with improving that. I'll not be able to cover all of them today, but like something like query classes or specification pattern or extension methods. But I will quickly skim through a couple of examples with specification pattern and extension methods. Really quickly go through them. There are sample code in the GitHub repository that will explain both patterns, and I will share the links at the end of the talk. Let's have a look at this example query. This could be just a query in a repository to get an active subscriptions for a particular customer. So we are getting the subscription that has the status active for a particular customer ID, and we do the mapping to return the entity to the database. What we have in here usually end up with large query condition, large query clauses. So you might have and, or, and parents here and there. So that query usually gets bigger and bigger. And that's why you end up with having this as a method, and you don't want to kind of repeat that method multiple times, and you wrap that as a part of your repository. But it's usually not readable, because even within the same repository, you might have two different methods, and you might end up repeating the same conditions in those two methods inside the same repository because of a slight difference. And the solution to that could be introducing a specification pattern. You have a base specification where you identify what is the criteria, like the where clause that will be used, the includes to find which other tables you will load from the database. You can also extend this to include like the sorting or pagination and so on. For now, we just have the criteria as an example. With that base specification class, I can start creating concrete specifications like get the active subscriptions becomes a class where I define the criteria, and obviously with more complex, I can identify the pagination logic, I can identify the sorting and different things that I would like to add. I can have another specification for the customer subscriptions. With those two specifications, I can have my own where method that accepts the specification. And this will, as we can see here, where new active subscription specification. And since the specification is isolated, I can reuse it across different queries. And the good thing is with that specification pattern, the generated SQL statement is exactly the same that was used when we used that where conditions directly. So we have a more usable approach, and I can share different specifications, and it becomes more of a Lego, right? I use different specifications to build my own query. However, with more complex specifications, this becomes a little bit more harder to read, and the class names gets bigger and bigger. The good thing is we can leverage extension methods to make our code more readable and encapsulate that behavior. So I can have something like context.subscriptions.getActive subscriptions for customer. So this is basically getActive subscription is an extension method that's wrapping that where method, and for customer is wrapping that where new customer specification. So my code becomes much more readable, and I can reuse those specification concrete classes as a Lego. There are different approaches as well that can help with that, but the key thing here is with this change in the code, I can basically sometimes not even need to have a repository in my code base. The next thing that I would like to talk about is having a base entity ID. My classes, as you have seen, inherit from a base entity, which have a primary key of GeoID. In legacy code bases, you might have a mix of tables that were using integers, which were created previously, and new tables using different data type like GeoID. You can solve this by using a base entity that's a generic, but even better, you can take this one step forward by using a strongly typed entity ID, like subscription ID here. That enables me first to add validation, so I can create only subscription ID if it's not empty. It also enables me to avoid errors by, if I have a method that accepts two GeoIDs, I can pretty easily send the wrong ID to the wrong parameter. So I can send the customer ID to the product ID parameter and vice versa. But if I'm using a strongly typed ID, I am leveraging the static type features of the C# because the compiler will complain if I passed customer ID to a product ID. There are a bunch of other benefits when you work with entity ID, like refactoring from the old integer ID to the new GID with your tables. That could also make your refactoring a bit easier. It might not be the first thing that you will do when you move towards more of a domain-driven design domain model or a rich domain model, but it's something that you really need to keep in mind and you try to push to it as you progress with your refactorings. That's all what I wanted to cover today. The slides are available. I will share the link on Slack. The demos also include all of the code that we have seen today with the before refactoring and the after refactoring. If you are looking more into that specification pattern, I have recently found this Stevie Smith specification library, which is doing a lot of covering of the behavior for different specifications, which includes pagination, sorting, all sorts of things. Thanks a lot for your time. I will look into the questions that you have sent over Slack, and I will answer them there. Again, thanks again for your time. I wish you enjoyed the talk. Please feel free to reach out with any questions that you have later over Twitter or Slack. Thanks again and enjoy the rest of the conference.